In this video, we're going to look at how you can find normal proportions under a normal curve in any situation. It basically uses the standard normal distribution and all the information we have about that. We're going to be able to answer questions like this. SAT math scores are normally distributed with a mean of 500 and a standard deviation of 100. What proportion of scores are less than 570? When you're answering a question like this, there's a sequence you could follow. Define the variable of interest. If you want to use a variable, which you definitely do in situations like this, you have to define what the variable is. Then state the proportion you're seeking. It's basically a mathematical translation of that question. And then you draw a sketch that indicates that proportion under a normal curve. You standardize your proportion. Just change your variable into a z and change your boundary value into a z-score, and then you solve using your calculator or a table, and then state your conclusion in context in a complete sentence. So working this example right here, the variable we're interested in is SAT math score, so we just define x to be SAT math score, and it's normally distributed with a mean of 500 and a standard deviation of 100. So that is our definition of the variable. Now the proportion we're seeking here is the proportion of these x's that are greater than 570, and in or less than 570 rather. And in this situation, you can just write this. This is the mathematical translation of all of that. In a picture, it looks like this. Draw an axis, put a label on it. You can use x. Draw your normal curve in. Put your mean under the peak. Put your boundary value in, and then shade the appropriate part under the curve. We're shading to the left of 570 because we're looking for the proportion of all x's that are less than 570. Next, we're going to standardize this. We're going to subtract the mean and divide by the standard deviation on both sides. And when we do that, it looks like this. We took away mu divided by sigma on the left. So these are all letters. And we took away 500 and divided by 100 on the right. These are all numbers. This right here is, by definition, z. This right here simplifies down to 0.7. So this is a simplified version of that statement right there. And we can find this proportion on our calculator with the table. It works out to be 0.7580. And then our conclusion is simply about 75.80% of SAT math scores are less than 570. Here's another example. IQ test scores. IQ test scores are normally distributed with a mean of 100 and a standard deviation of 15. What proportion of scores are greater than 89? Well, the variable in this case is IQ test scores, so we state that. X is IQ test score. It's normally distributed with a mean of 100 and a standard deviation of 15. The proportion we're looking for is the proportion of these scores that are greater than 89. So in mathematical language, that proportion looks like this. P of x greater than 89, close parentheses. The picture looks like this. We have an axis with a label on it. We draw the normal curve in. We indicate the mean. We indicate the boundary value of 89, and we shade to the right because we want the proportion of x's that are greater than 89. When we standardize this, we subtract the mean and divide by the standard deviation on both sides. And that's going to look like this. X minus mu over sigma on one side, 89 minus 100 over 15 on the other. That simplifies down to the proportion of z-scores that are greater than negative 11 over 15. And if you go to your calculator and find that, it works out to be about 0.7683. So about 76.83% of IQ test scores are greater than 89. Okay, this is all you need for a conclusion. You state the proportion that you found, and then you say what it is. Here's a third example. Men's heights are normally distributed with a mean of 69 inches and a standard deviation of 2.5 inches. What proportion of men are between 68 inches and 73 inches tall? Well, we're going to go through the same procedure to find the variable. In this case, that would be men's heights. So that's all we say. X is men's height. It's normally distributed with a mean of 69 and a standard deviation of 2.5. The proportion we're interested in is the proportion of these x's that are between 68 and 73 inches. So in mathematical language, we write that like that. So this is basically shorthand for most of that question right there. And then here is the picture. I drew an axis. I put in my variable as a label. I drew the normal curve. I put 69 here under the center for the mean, and then I put my boundary values of 68 and 73, and I shaded in between. This is a compound inequality. It's going to have finite boundaries on both sides, and we can shade that area in there above that interval. When we standardize, we have to standardize all three parts. So subtract the mean from all three parts, divide by the standard deviation in all three parts. In the middle, we're going to use the letters, mu and sigma, but on the ends, we're going to use the mean, 69, and the standard deviation, 2.5, here and here. And then we're going to simplify each of those down. The middle simplifies down to z, the left simplifies down to negative 0.4, and the right simplifies down to 1.6, and you can go to your calculator and find this proportion. It's about 0.6006, and your conclusion is about 60.06% of men are between 68 inches and 73 inches tall. Again, it's a very simple statement. It's pretty much just a restatement of this question as a statement with the proportion that we found put in there. Okay, and I always use about because all this is approximate. It's not exact. There is no distribution of heights that is perfectly normal, but approximately so. So this is an approximation, and so I'm a little bit circumspect about being dogmatic. I would say about that percentage of men are between 68 inches and 73 inches tall. So this has context. It's a complete sentence. The reader of your AP exam will understand what you're saying, and they will understand that you found the answer to the question that was asked.